The carbon cycle, how nature keeps life and atmosphere in perfect balance. There is a force so invisible, yet so fundamental, that it weighs every living thing on earth together in an unbroken dance that has lasted for over 4 billion years. Every second, billions of tons of carbon atoms move slightly from the air we breathe into the vast green canopies of the Amazon rainforest, through the bodies of bison on the Great Plains, into the red black soil beneath our feet, and deep into the vast blue oceans, only to rise again as carbon dioxide and begin the entire journey once more in a perfect, never-ending loop. It is the same carbon that forms the backbone of your body right now, same carbon locked inside the ancient redwoods of California, the same carbon that once fueled the dinosaurs is and now helps regulate the very air that keeps our planet's temperature in the delicate balance. There is not just the CO2 cycle you may have learned in school. There is nature's perfect balancing act, the carbon cycle. According to NASA's Earth observation and the latest Global Carbon Packages 2025 from the Global Carbon Project, the cycle moves approximately 200 billion tons of carbon through the atmosphere, land, oceans, and living organisms every single year. The atmosphere currently holds roughly 850 billion tons of carbon, mostly as carbon dioxide, with levels averaging from around 429 ppm as of early 2026, 52% higher than pre-industrial levels of about 278 ppm. And that until the rapid rise driven by human activity. In the last 2 centuries, the total amount of carbon on Earth has remained almost perfectly stable for hundreds of millions of years. Without this cycle, there would be no life as we know it. No lush green forests stretching endlessly across the Amazon basin, no towering redwood groves protecting the Pacific coast, no oxygen-rich air for Earth to breathe, no stable climate that allows civilizations to flourish. Earth would be either a frozen wetland or a scorching greenhouse like Venus or Mars. This is the story of carbon's incredible journey, a journey that connects every living thing on Earth, from the tiniest microbe in the soils of the Midwest prairies to the massive whales in the Atlantic Ocean, and keeps our beautiful blue planet's atmosphere alive in perfect, life-sustaining balance. Join me as we follow a single carbon atom on its epic voyage, from the invisible gas high in the sky to the miracle of photosynthesis in a rainforest leaf, into animals and food chains, down into the soil and deep oceans, and back again, revealing how the perfect system powers everything we know and love, with real-world examples you can see and touch right across the Americas today. Have you ever taken a deep breath on a cool morning while walking through Central Park in New York or along the shores of Lake Michigan in Chicago? Feeling the fresh air fill your lungs and wondered exactly what invisible molecules you are breathing in, or stood on the balcony of your apartment in Los Angeles on a hazy afternoon, looked up at the sky and asked yourself why the atmosphere feels so perfectly balanced that life can thrive year after year, that sometimes feels heavier during a heat wave or wildfire season. That every moment, everyday moment is exactly where the carbon cycle begins, in the vast, invisible reservoir of the atmosphere, where carbon exists primarily as carbon dioxide, a colorless, odorless gas that makes up only about 0.0429% of the air right now. According to the latest measurements from NOAA's Lunar Observatory and NASA's Earth Observatory, the global atmospheric sea carbon dioxide concentration averaged 422.8 ppm in 2024 and is projected to reach approximately 425.7 to 429 ppm by the end of 2025, early 2026. Before the Industrial Revolution in the mid 1700s, levels had hovered stably around 278 ppm for thousands of years, thanks to the natural carbon cycle keeping things in equilibrium. Today, that tiny percentage of carbon dioxide acts as the planet's thermostat through the greenhouse effect. It allows sunlight in but traps some of the heat radiating back from Earth's surface, keeping our average global temperature at a livable 15 say instead of a freezing 18. Picture a single carbon atom floating high above the Amazon basin. Right now, it is part of a massive dynamic reservoir that holds roughly 850 billion tons of carbon at any given moment. The carbon is constantly exchanging with the land and oceans. In the Americas, warm air over the Atlantic and Pacific can hold more moisture and dissolve carbon, while trade winds and weather systems carry atmospheric carbon dioxide across continents, interacting with vast forests and farmlands. Have you ever noticed how the air feels thicker and more humid during summer in the Midwest or after a rainstorm in the Pacific Northwest? That is partly because higher temperatures and humidity accelerate the natural exchange of carbon between air, water, and plants. The greenhouse effect is not inherently bad. It has kept Earth habitable for billions of years, but the rapid rise in carbon dioxide, driven largely by human activities, has pushed levels higher than at any time in the last 2 million years. Across the Americas, this means more intense heat waves in the southwest United States, stronger hurricanes in the Caribbean and Gulf Coast, and rising sea levels threatening coastal cities from Miami to New York. According to NASA data, these changes are already altering weather patterns and ecosystems from the Amazon to the Arctic. That the atmosphere itself is only one small piece of the puzzle, the first carbon cycle that keeps life moving. Without this invisible starting reservoir, there would be no raw material for plants to capture and transform into the energy that sustains every food chain, every plate, and every meal on your table. This stage sets the foundation for the entire cycle. It is the quiet cloud bank from which carbon is withdrawn by living things and to which it eventually returns, maintaining the delicate balance that allows forests to grow, crops to flourish, and humans to thrive across the Americas and the world. As the carbon atom drifts downward on the wind currents over the Amazon rainforest, something truly miraculous happens the moment it meets a vibrant green leaf swaying in the canopy. Have you ever hiked through the dense understory of the Amazon in Brazil, or stood in a vast cornfield in lower during the growing season, watching the bright green plants sway in the breeze, and wondered how the humble leaves turn an invisible gas you cannot even see into the fruit or an oxygen that sustains life across the Americas? Or driven through the redwood forests of California and ask yourself how the towering trees are quietly cleaning the air while storing carbon for centuries? The answer is photosynthesis, the elegant biochemical process that pulls carbon out of the atmosphere and locks it into living tissue, releasing oxygen as a precious byproduct. According to NASA, plants, phytoplankton, and algae on land and in the ocean absorb about 120 billion tons of carbon from the atmosphere every single year through that process. In the presence of sunlight, chlorophyll inside leaves and cells combines carbon dioxide with water to produce glucose, a form of sugar that stores energy, and oxygen. The simplified equation as say carbon dioxide plus say water H2O plus sunlight transform to C6H12O6 plus 6 oxygen. That glucose becomes the building block for stems, leaves, fruits, and grains, literally turning air into food and life. In the Americas, the process is happening on an enormous, visible scale every single day. The Amazon rainforest, alone the largest tropical forest on Earth, absorbs billions of tons of carbon annually through photosynthesis, acting as one of the planet's most powerful lungs. A single hectare of healthy Amazon forest can sequester 5 to 10 tons of carbon per year. Even more impressive are the temperate rainforests of the Pacific Northwest in the United States and Canada, where ancient redwoods and Douglas first stored massive amounts of carbon in their massive trunks and roots. Some invisible trees holding hundreds of tons over centuries. Cornfields across the Midwest United States also play a major role. A single hectare of corn can fix 8 to 12 tons of carbon per growing season, turning atmospheric carbon dioxide into the grains that feed livestock and people across North America. Imagine that same carbon atom from the atmosphere entering a leaf in the Amazon canopy. Sunlight powers the reaction inside the chloroplast. The carbon becomes part of the sugar molecules that fuel the tree's growth, travel through the vascular system, and build the gut. And leaves that form the rainforest structure. Some of the carbon is released back into the air when the plant respires at night, but most stays locked inside the biomass until natural decomposition or disturbance in the redwood forest of California. The same process happens on a grand scale. The trees burn carbon dioxide from Pacific winds and store it in trunks that can live for over 2,000 years, creating some of the largest carbon stores on land. That stage is the beating heart of the first carbon cycle, the magical moment when inorganic carbon from the air becomes the organic building block of all life on Earth. Without photosynthesis, there would be no plants, no animals, no oxygen for Earth to breathe, and no stable climate. Across the Americas, It is the reason the Amazon remains one of the most biodiverse places on the planet. The muskrat produces the food that feeds nations, and the redwood groves stand as living monuments to carbon storage. Every bowl of corn, every breath of fresh air after a rainstorm in the Pacific Northwest, every piece of timber from sustainable forests is a direct gift from the invisible to visible transformation. Once carbon is captured and transformed by plants through photosynthesis, it begins its next great journey through the intricate web of life, moving from producers to consumers in a living chain that connects every creature on the planet. Have you ever sat down to a simple family meal of grilled steak from muskrat beef or fresh salmon from the Pacific Northwest and realized that the energy and nutrients on the plate started as carbon dioxide floating in the sky just a few months earlier, or what a herd of bison grazing peacefully on the tall grass prairie in Kansas, and wonder how the animals' bodies are literally built from the same carbon that was once invisible gas. Animals cannot pull carbon directly from the air like plants do. They must obtain it by eating plants or other animals. They transfer through the food web moves billions of tons of carbon through ecosystems every single year. Herbivores such as bison on the Great Plains, deer in the forests of the eastern United States, or cattle across the pampas of Argentina graze on grasses and leaves, incorporating the carbon into their muscles, bones, and organs. Carnivores and omnivores, like the salmon swimming up rivers in Alaska, the goats in Yellowstone, or humans enjoying a backyard barbecue, then consume that carbon-rich food, passing it further up the chain. According to NOAA and NASA data, the biological transfer is a key part of the fast carbon cycle, with respiration from animals releasing some carbon back as carbon dioxide while the rest continues moving to the web. In the Americas, the cycle is beautifully visible in iconic ecosystems. In the Amazon, carbon fixed by rainforest trees, fish, insects, birds, and monkeys, which in turn support jaguars and other predators. On the Great Plains, carbon from prairie grasses moves through poison and prairie dogs, then into predators like corridors, maintaining the rich grassland ecosystems that once covered vast areas of North America. In the Pacific, salmon runs up the Pacific Northwest. Carbon captured by ocean phytoplankton is eaten by small fish, which are consumed by salmon, which then swim upstream to spawn and die, delivering marine carbon deep into forest soils and feeding pierce eagles and entire river ecosystems. A single kilogram of beef or salmon you eat contains carbon atoms that were atmospheric carbon dioxide only months ago. The animal on your plate may have passed through 3 or 4 living organisms in that short time. When animals breathe, they release some carbon back into the air through respiration, closing small daily loops while keeping the larger cycle alive and balanced. The study reveals how carbon connects every single creature in an unbroken chain, from the tiniest zooplankton in the Atlantic to the largest predators in the Amazon or Yellowstone. It is the living breath that turns captured carbon into the energy that powers movement, growth, and life itself across the Americas, from the ranches of Texas to the rainforests of Brazil. When living things eventually die or shed leaves, roots, and grit, the carbon they contain returns to the earth in one of the most important and often overlooked steps of the cycle. Have you ever hiked through the forests of the Pacific Northwest after the leaves have fallen and noticed the rich, dark, almost like sorrow under your feet that feels soft and full of life? Or driven past harvested cornfields in Lower and wondered where all that leftover plant material and its stored carbon actually goes, and once it breaks down. Decomposition is the next vital state. Bacteria, fungi, insects, and microscopic organisms in the soil break down dead plants, animals, and waste, releasing some carbon back into the atmosphere as carbon dioxide or methane, while storing the rest up as organic matter in the soil. According to NASA and USGS data, soils worldwide hold an astonishing 1,500 to 2,004 billion tons of carbon, more than the atmosphere and all living plants combined. This stored carbon improves soil structure, holds water, and provides nutrients for future plants, creating a natural fertility loop that has sustained agriculture for millennia. Across the Americas, this process is happening on a massive scale. In the Amazon, fallen leaves and branches create thick layers of organic rich soil that store carbon for centuries. In the Midwest United States, when crop residues from corn and soybeans are left to decompose instead of being burned, carbon builds up in the prairie soils, naturally enriching them for the next season. In the redwood forests of California, decomposition of fallen needles and branches builds deep carbon-rich forest floors that can hold carbon for hundreds of years. Some carbon is released slowly as carbon dioxide or methane, but much stays buried. Nature's long-term savings account. Have you ever noticed how the soil in a healthy forest or prairie stays moist and dark even during dry periods? That is decomposition at work. Without their return to earth state, soils would become depleted, crop yields would crash, and entire ecosystems would collapse. This state completes the land-based loop of the carbon cycle. Carbon that was once high in the sky, captured by plants, passed through animals, now returns to the ground, enriching the very soil that grows tomorrow's forests and crops across the Americas. Not all carbon stays on land. A huge portion of it finds its way to the oceans, where it is stored on a truly planetary scale. Have you ever stood on the beach in California or Florida at sunset, watching the waves gently crash, and realized that the vast Atlantic and Pacific Oceans surrounding the Americas are quietly absorbing enormous amounts of carbon from the air we breathe and the activities happening on land? I wondered how the ocean can act as both a life-giving resource and a massive carbon sink that helps slow down climate change. Oceans are Earth's largest carbon reservoir, holding about 50 times more carbon than the atmosphere and absorbing roughly 25 to 30% of all human-emitted carbon dioxide each year. According to NASA's and the Global Carbon Project's latest data, surface ocean waters dissolve carbon dioxide directly from the air, while phytoplankton, tiny marine plants, perform photosynthesis on a massive oceanic scale, fixing carbon that then sinks at marine snow when the organisms die and fall to deeper layers. Along the coast of the Americas, mangrove forests in the Caribbean, seagrass desert of Florida, and capped forests in California act as powerful blue carbon factories, burying carbon in sediments at high rates. Picture a carbon atom that dissolves into seawater near the mouth of the Mississippi River. It may be taken up by phytoplankton, eaten by small fish, incorporated into shells and coral, or chemically converted into dissolved bicarbonate. Some of the carbon sinks to the deep ocean, where cold temperatures and high pressure keep it locked away for hundreds of or even thousands of years. However, the oceanic absorption comes with a cost. Ocean acidification. After carbon dioxide lowers the pH of seawater, making it harder for corals, shellfish, and plankton to build their calcium carbonate structures along the coast of Florida and the Caribbean. This is already affecting coral reefs and the shellfish industry. This stage demonstrates the truly global nature of the carbon cycle, land and sea working in harmony to keep atmospheric carbon levels from rising too quickly. The ocean has absorbed about half of all human-emitted carbon since the Industrial Revolution, being at Earth's thumb, but it cannot do so indefinitely without consequences. For hundreds of millions of years, the carbon cycle maintained a beautiful self-regulating balance. Now, starting with the Industrial Revolution and accelerating dramatically in the last century, humans began adding extra carbon at a rate the natural system was never designed to handle. Have you ever driven through the streets of Los Angeles during rush hour, seen the smoke rising from factories in the industrial Midwest, or watched cargo ships burning heavy fuel in the Gulf of Mexico, and wondered how our modern daily life is quietly changing that ancient, perfectly tuned cycle, or heard news about stronger hurricanes hitting the Gulf Coast and wildfires raging through California and the Amazons, and ask yourself why these changes are happening faster than ever before. According to the latest Global Carbon Practice 2025 and NASA's IPCC data, human activities now release about 11.6 billion tons of carbon (ZTC) into the atmosphere every year, primarily from burning fossil fuels, coal, oil, natural gas, cement production, and land use changes like deforestation. There is roughly 10 to 12 GTC annually from fossil sources alone, far exceeding that what natural sinks can fully absorb. Across the Americas, deforestation in the Amazon for cattle ranching and soy farming, urban sprawl in the United States, and fossil fuel extraction in the Gulf have released millions of tons of stored carbon while destroying future carbon sinks. The result is clear. Atmospheric carbon dioxide has risen from 278 ppm pre-industrially to over 429 ppm today, the fastest increase in millions of years. The actual carbon traps more heat, leading to rising temperatures, more intense hurricanes, prolonged droughts, and wildfires that have devastated forests from California to the Amazon. That nature is still working hard to restore balance. Forests and oceans continue to absorb roughly half of our emissions. The question is whether we will help them or continue to overwhelm the cycle that sustains Earth. Every single breath you take, Every grain of corn you eat, every tree you plant connects you directly and intimately to the carbon cycle in ways that go far beyond sun. Have you ever paused during a morning walk in a park in New York, taken a deep breath and realized that the oxygen filling your lungs and the carbon in your own body were once floating high in the atmosphere, captured by a corn plant in lower or redwood in California? Or looked at your children playing in the fields and wondered what kind of world we are living them if we do not restore the balance of this cycle? You are literally made of carbon. About 18% of your body weight consists of carbon atoms. The carbon in your cells, the bones, your muscles was once carbon dioxide in the sky, fixed by plants through photosynthesis, passed through food chains, and now part of you. Scientists estimate that the average human body contains about 16 to 18 kilograms of carbon. That carbon is constantly being renewed through the very cycle we have explored. We are not separate observers of the carbon cycle. We are as living participants, temporary custodians of a system that has no true beginning and no end. When we protect the Amazon, restore forests in the Pacific Northwest, practice sustainable farming in the Midwest, or support policies reducing fossil fuel use, we actively have restored the natural balance. When we continue high emission lifestyles, we tip the scales. The carbon as your body right now has likely circled the planet hundreds of times over millions of years, linking you to ancient oceans and future generations. That realization takes both humility and hope. The carbon cycle reminds us that everything is connected. The air we breathe, the food we eat, the climate we experience, and the future we build across the Americas and the world. The carbon cycle will continue as perfect, elegant dance long after our tallest buildings have changed names. Our stories have faded into legend, and humanity itself has evolved into whatever future form awaits Earth. It will keep moving carbon from the invisible air into green leaves, through animals and food chain, down into rich soils and deep oceans, and back again, quietly, alertly, and tirelessly, trying to maintain the balance that makes life possible.